Mr. Pansini.
Say good morning.
Good morning, Flash.
Hello.
Hey,
Big shout out to Valerie Lucky.
No.
Okay.
Tommy is a cheese omelet.
Shout out to all the pair.
All right,
Fire.
guys, you have to know your property rules, and that's what we're going to put on the note cards as we go through this. You have to memorize them. You have to know them. If you don't know them, you're not going to be able to do this stuff. Okay. All right. What? Do you guys know what prefix means one? Mono. You guys know that?
Yeah.
Mono. We're going to call a monomial. Okay, make sure we spell that right. M-O-N-O, M-I-A-L. Okay, it's a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. OMG, that's a mouthful. Okay? All right, here's how you think of a monomial. It is only one term or one piece. One term or one piece is a monomial, hence the prefix mono. Audrey, give me your favorite number in between 1 and 10. 5.
6.
9.
12. Okay, guys, 5 is a monomial. Okay? Blake, give me your favorite variable.
One digit variable. Boom. T.
T. T is a monomial.
These are
Oh, I have one.
Okay?
What did we just do in
Now, wait. It's not only a number or a variable, it's the product of numbers and variables. So, 14Z. Jot it down. Focus. 14Z is a monomial. And kids are always, but it's two things. It's 14. But as long as it's product, okay, product means multiplication, you're good to go. It's one piece, one thing. Watch this. Negative 6,412 a squared b cubed c to the 9th power d is a monomial.
Can you do like times the quarter?
Hold on, I'm going to get to that.
Yay.
Right here. Okay. Negative 7,412 8 squared b cubed c to the 9th power d is a monomial. You would never have to do anything with that. You just know that it's a monomial. $10,000 question of the day. What's not a monomial?
Binomial.
68.
42 plus
No,
8.
68 is a monomial.
Oh, wait, I'm in 68.12.
No, that's still a
48
monomial.
48 plus 1.
48 plus 1 becomes 49, so technically it is a monomial.
48 plus Z.
There you go.
I don't
Not a
understand. Why
monomial.
is it not a monomial?
George on 10,000.
48 plus z. Guys, pieces or terms are separated by plus and minus signs.
Oh.
Pieces or terms are separated by plus and minus signs. Somebody knows this already. This is not a monomial. It's a binomial. Why is it bi? Bi means two. What if it has 3 pieces? Trinomial. What if it has 4 pieces? No, there's no such thing as a quadnomial. It's just considered a 4-term polynomial.
Poly meaning many.
Got it. All right. More on that later. An expression that involves division by a variable, such as xy over z. Okay? If there's a variable in the bottom, it's not a monomial. Okay? And the reason is kind of what Jack's Gardner's saying. It's because. Let's write this down. Because variables in denominators I can never spell that word. Because variables in denominators have negative exponents on them. I don't see no negative exponent on that. Guys, there's a negative exponent on that z. Just so small you can't see it though. It's there. Look at Gia's like. Guys, once we start dealing with negative exponents, you'll be like, oh, I understand why there's a negative exponent. Guys, first of all, there's an exponent on everything in the world. It's just not. There's a 1. If it's in the bottom, it's a -1. So there's really a -1 on that z. We're just not going to write it. You're not going to see it. But that's why you cannot have. It's not a monomial. All right. Well, that'll make sense as we go on. All right. A constant is a monomial that is a real number, i.e., no variables. Somebody raise your hand and give me a constant in between 40 and 50. Bulls. 41. That's a constant. And they call it a constant because it is constantly 41. It's the opposite of a variable. Variables vary from problem to problem. 41 is 41 all the time. It's constantly 41. So any number is a constant, as long as it doesn't have a variable with it. All right, determine whether each expression is a monomial. Write yes or no. Then explain your reasoning. Go, do those 5 problems. Right, yes or no. And then you don't have to write down your explanation, but just think about your explanation and say it when you give your answer. Okay? Counterboy, A, monomial. No, why not? Because it's 2 pieces. It's got a plus sign in between there. B, Murph.
Yes.
Yes, why?
Because everything, it's not separated by plus or minus.
I would accept that answer, or I would say it's all multiplication. Okay? C, Naughton.
Yes.
Yes, why?
It's 1 piece.
It's 1 number. Very good. All
Anything?
right, D and E, be very careful with both of them.
Yeah, I don't know.
Make a decision. Think about what we've learned and what we've talked about. Val, D.
Yes.
What?
Because there's a number
Hey.
underneath and not a variable.
Oh.
It's a number. You can divide by. We know what 3 is. It don't have no negative exponent on it. It's actually, and you guys will get this.
Oh, I understand.
$10. Good point. Hey, $10 if you can write x squared. X squared, is that a squared or cubed?
It's a square.
X squared y over 3. How could you write it a different way so that maybe kids would understand that it's definitely a monomial?
X squared.
Your hand raising means you're going to say something. Don't say anything. Paige,
Oh, never mind.
how would you? Anybody else want to try to write it?
X squared, y divided by a sign.
Oh, he wants to use old-fashioned. That's good, but I don't think that would make it clear. But you're totally right. What would you do?
-3.
No, it's not negative. We know it's not negative. But good try though. How about this? 1/3 x squared y.
Oh.
Right? Isn't that the same thing? Isn't that the same thing as x squared y divided by 3?
Yeah.
Sweet. All right, last one. Yes or no?
No.
No. Variable in the denominator. I'm gonna write that reason down. That's basically when it looks like it might be a monomial. If there's a variable in the denominator, no. Variable in denominator, big no.
Is there homework kind of just yes or no?
Oh yeah, you got 40 problems. Yes or no?
Yes. I wish. It's still 40 something.
And Sarah,
I'll be here being sarcastic.
You've been doing
I
so
know. I said I would.
you've been doing so good about thinking before you ask those kind of questions.
I'm so happy.
All right. Now let's talk about our first rule here. All right, let's expand. Let's say you're going to multiply 7 to the 5th times 7 cubed.
7 times 7.
Okay.
7, 8.
If you expand that, think about how many 7s you would write.
8.
Everybody agree? 8? So, because 7 to the 5th means 7 times 7 times 7 times 7 times 7, 5 of them, times 3 more of them. 7 times 7 times 7 times 7. And, so, guys, I'm going to say a lot. Expand something. That means write it without an exponent. Now, condense it.
7, 8.
Say it the right way, though.
7 and 7 is 8.
You guys just learned rule number 1. No, I don't want the answer. It's too big. It's a big number. Don't worry about it.
Is that
Amanda.
equal 7?
It equals 7 to the 8th power.
Oh, okay.
Okay? Now, all kinds of knucklehead things I see. Do not write this down. 49 to the 15th.
Do they multiply? Or they add
It says multiply, so multiply. That they multiply the base and they multiply the exponents. Morons. Okay. It's 7 to the 8th power. It's an extremely big number. I don't care what it is. We're dealing with exponents today. So, what if you change that and start dealing with variables instead of numbers? What do you think x cubed y squared times x to the 4th y is? Big hint. Expand it and then condense it. No, because you're going to learn the rule in a minute. Okay? If you're not sure what it is, everybody expand it and then condense it and see if you can figure out the rule. Okay? Val, what do you know?
X to the 7th power times y cubed.
Correct. You were correct. Let me write that out though. Everybody, you do not have to write this out on your homework. You're not going to have 40 problems for expanding all this junk. You're going to use your rules. Times y times y times x times x times x times x times y. If we condense it, I got 1, 2, 3, 4, 5, 6. X to the 7th, y to the. Did I do that right?
I wrote them all next to each other.
Oh, you regrouped them?
Yeah.
That's fine. And again, Bobby will not do that in your homework. You're going to know the rule. And then y to the 1, 2 cubed.
Don't you just add together the exponents?
Right, that's the rule.
Okay.
Say again?
No.
No. I'm going to teach you the rule, Blake, here in a second. So, can you come up with a rule that would help us simplify these expressions without expanding them every time?
Add the exponents.
Add the exponents. But you can only add the exponents if what? That's considered the base, right? Base is same. Base is same. Add exponents. We did this last year. We did it. You were not going to believe the stuff that we do in Chapter 7.
Well, we have to memorize like exponent,
The rule?
like no, but like 2 times, like 2 times,
Yeah, you have like
I don't understand what you're asking,
we
Mike.
like wrote it down on note cards and kept like writing like every single number.
No, you're going to know the rule. I still don't
Yeah,
understand.
we made us
What's he
memorize
asking,
like
Paige?
2 times.
Paige, what's he asking?
He's asking if we're gonna have to memorize the cube numbers and the squared numbers.
Oh, no. No. You can use your calculator, but you're going to be dealing mostly with variables.
Oh.
You're going to deal mostly with variables. All right, let's jump to the back and get a note card out because you're going to learn rule number 1.
Wait, I thought
Note card out, 1 note card, and the notes at the same time. We don't have much time. Okay.
I was like, where's the line?
The name of the property is not on the notes. I'm trying to think of it. The other one's on the notes.
Let's call it.
It's got a name. It's got a name, and we need to write it down.
Can we call it?
It's not same base formula.
Same.
It's correlation.
Hang tight. Let's see, chapter 7.
She's like, do you want to be my sister?
That was pretty. That's good. If you're Blake.
No.
I don't know if anyone else like that.
I'll be honest.
Product of power. I guess it is product of powers.
Spend like 5 minutes on it.
Just one of them like that.
Plays well.
No.
Oh, yeah, product of powers. That is it. My bad. All right, guys, on your note card, write product of powers. Rule. This is rule number 1. That's what this is going to be called. Product of powers. Because you're multiplying with exponents. Product of powers. Okay, and for any non-zero number A with integers m and n, the exponents have to be integers. That'll make sense once. So a to the mth power. I love saying mth. Everybody say mth. Times a to the nth power.
Yeah.
Everybody say nth. Notice, what's the same?
The base.
The base has to be the same. That will equal, and here's the rule you should use on your.
AMN.
No, you're not going to multiply.
A to the
A
mn
squared
power.
times
Classic
A to the mn power.
Guys, you just learned the rule, and all of a sudden you're multiplying your exponents together. You're being awful.
A to the
A
M.
to the n plus n power.
M plus n power. We add our
Oh,
exponents.
don't put them all up top? Yeah, okay.
And I'm going to write it. And I say it, a to the m plus n power. Okay? Now, this will make sense. When Jack was getting all bent out of shape about 40 problems, some of your problems are like number 2. Okay?
Are you kidding me?
So,
Easy.
5 cubed times 5 to the 9th. Do not grab your calculator and type that in. Your job is to leave it with an exponent. Okay?
Wait,
So, I'm going to write out how to get it, then you don't have to write this step out. You would go 5 to the 3 plus 9 power, there's applying our rule, which equals 5 to the 12th.
We just
And you would just
Yes,
write 5 to
you
the 12th.
can.
Okay?
You have to write out
For number
5.
4, would
No,
we
you do not have to write out. I'm just showing you how we got it.
Okay.
You are smart enough and good enough that you are to the point where you just go 5 to the 12th. Just know your rule. What's the next one? Because there's that little sneaky p in the middle. Makes things tricky.
p to the
It's
8th?
got a little
P to the
sneaky.
eighth.
Hey, it's got a little sneaky 1 on it, so it's p to the 8th.
Wait.
See, how would you do number 4? Would you multiply?
I'm gonna
No,
get
you
there.
don't multiply.
I'm gonna get there. So the number 4 is tricky because everybody's got to be careful with their coefficients.
It's just X.
No. You do not. Hey, do not start adding coefficients together when you multiply. That's what kids always do. They think it's -1 x to the 10th. No. The
Classic.
Bobby, I'm gonna go to you on this.
2,
Are the
Negative
4?
20.
Listen. Are the 4 and the -5 exponents or coefficients?
Coefficients.
Guess what you do with coefficients?
You multiply them.
You multiply those
Negative
together.
20. X.
So
So
it's gonna be
20
-20
x to the 10th power.
x to the 10th.
Are you there?
That's tricky. So you guys gotta think. If you just go to your homework tonight and start doing, you're gonna miss a lot of them. If you go to your homework and start thinking, you're gonna get a lot more right. Okay? Now we're gonna throw more than just one variable at you. There you go. Don't say it out loud. Everybody try it. When you think you are confident you got number 5, raise your hand. Everybody in here can do it. I would. When I started learning this in high school in freshman year, Mr. Sproat, okay,
Yeah.
I would think of this as 3 problems.
Beer salesman.
Liquor bucket. 3 problems. Coefficients, x's, and y's. If you break it up into 3 problems and think of it that way, you will get them right. Who wants to take a risk and try this one? Buckley, give it a shot.
21 times x times y to the 6th power.
Is he right? Y to the 6th? Yeah, it's a 5 in there. Nice.
Oh, yeah.
21x, y to the 6th. Does everybody understand about how I see it as 3 different problems? Coefficients, x's, and y's. Do the next one. Oh, think about that one as 4 different problems. Do not get bent out of shape. 4 problems. Coefficients, r's, x's, and t's. Do it. Everybody here can do it. Look carefully, Bob. Break it up.
I have.
Gia Tortilla.
24 r to the 6th, x to the 4th, t to the 4th.
Done.
I got it right.
Same
The next one's hard.
I got that one.
Okay? Great job. 4 problems. So -4 times 6 is -24. No, it's -4 times -6. Positive 24. R times r to the 5th. Well, I know that's r to the 6th because I have my exponents. X squared times x squared is x to the 4th. T cubed times t is t to the 4th. 4 problems. Do the next one. Do it. You guys can all do this.
Is there some kind of catch to this one?
No.
Just like
Catch
Uh,
21.
What are we
Oh,
supposed to be writing
are
down?
there coefficients? Yes, you just can't see them, so be careful with that. And the negative signs matter, guys. You know that. Not take a risk.
Negative a to the 7th power, b to the square power,
I knew it was.
What power? B to the what power?
b squared,
Squared or to the 2nd power. I don't care how you say it.
and c to the 5th power.
Dude, you were the man.
Hey, Jack.
Why is it negative, Jack? Can you explain it?
Because it's negative a times a.
Yeah. Guys, think about how many negative signs there are. How many negative signs are there in that problem?
1.
1. And that's going to change. It's going to get weird in a minute. There is going to be a catch, a trick. There's one negative sign. Here's what kids think. Do not write this down, but think about how kids think about it. They see negative a squared, and they think that squared is on the negative side. It's only on the a.
That's silly.
Does everybody agree with that?
Yep.
The beginning of that problem, they see negative a squared. They think they're squaring the negative sign. But no, that's only on the a, not on the negative sign. When would it be on the negative sign?
When it says negative a to the negative second power.
No. When the exponent is outside the parentheses, this thing, negative a squared. There's a difference, you know. That is positive a squared. Okay?
Yep.
Yeah.
Because you're squaring the negative sign there because the way the parentheses are written. And now you're going to have those here in a minute.
We did that last year.
Just be careful, guys, and think. All right. Next one, go. O, M, G. Start thinking.
Not my good stuff.
Use your rule.
Oh, I think I know.
Use your rule.
So, what would you go? 27.
Oh, no.
No, okay.
Base is the same with exponents. Keep the base the same. Never multiply together.
Oh.
No. Do not multiply those bases. I'll give you a hint. The answer is going to be 3 to the some power.
3 to the x to the second power.
I thought it was 27.
New.
27.
What? Not
All right. This one, we'll write this one out one time so you see it.
It's not
It's
good.
it's 3 to the x plus 2 plus, no,
1.
1.
Oh, I guess.
Look how we did that.
You combine.
Because
Oh,
And
no.
then you're going to combine your like terms again after you see this one written out one time, you guys will be able to do this one without writing it out. Who's got the answer? Combine all your like terms. You can do this. Brander.
Same deal.
3 to the 2x plus 2 plus 1. Or
Well,
2 plus
combine your
1,
2 plus 1.
Yeah.
3 to the 2x plus 3 power. You're going to have something like that. Welcome to algebra, people. Okay. Do we know x? The value of x?
No.
No. Do we care?
No.
Okay. It's 3. All we did was add up our like terms. Try the next one.
Wait.
Write it out. If you don't think you can do it in your head yet, write it out. And think of it as 2 problems. X to the a plus 2a power times y to the 3b plus b power. All I did, guys, was use the rule and show some work. Okay? Combine your like terms. Mike K, what do you think?
X to the 3a power and y to the 4 power.
X to the 3a times y to the 4b. We're just putting them next to each other. 4b. Sorry. All right. So. Oh my gosh, are they? Oh, they are asking to find the area. I thought they were going to put another binomial down here, and I was like, these guys don't know how to do that yet. But as long as it's a monomial down here, you guys can do this. All right. We're going to find the area of this. Okay, we did a lot of perimeter problems last section. Perimeter was add up all the sides. Area is multiply length times width. Is everybody agree? So, area is going to equal, I always put my monomial first, because you guys will see why. 8x times 3x plus 6. And I put parentheses around that binomial. Whenever you have a binomial, guys, and you're multiplying, throw parentheses around it. Now, let's simplify this. What property are we going to use here?
Distributed.
Everybody distribute your 8x and think about the rules we've talked about today. Let's go. Try it. What's 8x times 3x?
24 to the 2x power.
Oh,
That was kind of not really coherent, but what were we saying?
24 to x plus 2.
Why did you say the exponent before the variable?
X
Squared.
squared.
Right? Or you say x to the second power. I think that's what you want to say. So 8x times 3x is 24x squared. Where did the squared come from?
There's 2 x's.
Well, what are the exponents on those x's?
1.
What's 1 plus 1?
2.
2. Plus, what's 8x times 6? And this is the point where some kids like you can't do it because they're not like terms.
48.
But guys, we're not adding them. We're multiplying them. What's 8x times 6?
48.
48x. No exponents besides there's this little sneaky one there. But you know. Now, can you add those two things together?
No.
No, they're not like what?
Not like terms.
They're not like terms. Blake, what's your concern, my friend?
Surely during the last unit we could have at some point multiplied a variable by to be the same variable. So how come we didn't get like the squared version of that during it?
That's a good point. Don't worry about it.
So how
Deal with
come
the
we
rules.
didn't get those problems wrong is what I'm trying to say.
What is this
We
one?
did not find area last chapter. We're doing perimeter. Does that make sense?
Yes.
Okay. All right.
What are we supposed
Keep
to write
going,
on
guys.
the
You're
note
doing
card?
great. Last page.
Wait, then what are we supposed to write on the note card?
Oh, the note card was the. If you haven't done that yet, power.
Product of power.
Thank you. Product of power rule on your note card.
And that's all we write?
Product of power rule.
I had AM.
Yeah, and then let's write. So here's your note card. So you write power because we're gonna have a bunch of rules eventually. Power of product is a to the nth times
Product of power.
power of product.
You said you could
Product
say
of
power.
powers
You
rule,
could
that's
say
what you
product
said.
of powers.
I think that is what it is. Product of power.
So it's staying all night.
No,
It is
Missing
product
Power, he's saying.
of powers rule,
Oh yeah, I wrote an S.
which is a to the nth times a to the mth equals a to the n plus m power. It's just the rule that tells you if the bases are the same, add your exponents. That's all that one's doing. We're going to have more rules. Okay? All right. This one, I'm just going to do this one real quick because I know we're hurting for time. Put your right angle symbol in there. That was supposed to be drawn in when we did the notes. It's got to be a right angle.
We have to multiply this by half.
So that's my question. Is how do you find the area of a triangle, guys?
Half
Base
times
times
height.
So I'm going to go
Oh,
a half.
base times height divided by 2.
Or you can multiply them together and divide it by 2. Either way will work. Times 2x cubed y to the 5th times 12xy. So this one, guys, you know, I've been saying you don't really have to show much work. When you get to the area problems, probably write it out. 3 problems. You do in your head. Do the coefficients first, the x is second, and the y is third. Okay? Bowls. What's a half times 2?
1.
Times 12. X cubed times x.
X.
Y to the 5th times y.
X to the 6 or y to the 6 power.
Done. Guys, doing it as 3 problems makes sense. What happens is you guys look at all of this and are like, it's crazy. Okay? Wait, we got to do one more problem.
Get out right now.
All right? Power. Wait. We will do the power of a power tomorrow. So the homework, Jack Naughton, will probably be changed. Don't start the homework till after
School.
no,
Lunch.
7th period. Do not start now. I will change it.
I won't
for us.
really post it after.
Check my website instead of checking the syllabi. The syllabi is probably going to be wrong. Check my the daily team website. We will hit power of a power tomorrow.
Wait, so like, can you press
Hey, think tonight and do it as 2 or 3 or 4 problems at a time. Don't look at the whole thing, all those numbers, and get confused.
Mr. Pantini said we get to try. It's on the teammate one.
Yes, the Team 8-1 website, not the syllabi. I might change both of them, but I gotta see what Furlong's feeling. Hey, what kind of t-shirt, size t-shirt do you want?
Medium.
Medium?
Wait, what is this for?
The Google t-shirts.
Oh.
Gia, what size t-shirt?
Small, I'd say.
I got it.
On the back.
Really catch.
Stop throwing books, Matthew. It's not polite.
Here's a catch.
Fuck is.
There's a catch. Catch.
I didn't do it.
I need that math.
Are we turning in?
Yeah, I'm still the first one to
My
turn
math
it in.
homework
I was
was
just the
in
first one
my
not
math
to
section.
name
I'm
on
just
it.
gonna find it today.
Maybe you should put your name on it, Jack. Yeah, I got it. Alright, what am I gonna do about it? Alright? This is the way I wanna be. Let me live my life. Pink game to 26. I don't know what's what. You wanna be a pink dancer? I don't hate. So why do you hate on me?
Yeah.
I have full respect for pink dancers. Good. But girls 12 is not getting any respect right now. Sorry, I'm girls. Wait, where are the answers? Oh.
Where are the answers to the 408? Then you also had to do 408. No, for the ones that were coming in.
Can we turn on the one that was rated yesterday?
Get yourself.
Alright, do we turn in this one? Do we turn in 401? Is that page 401? Yeah, where do we turn that in?
Get.
Wait,